Hey there. So, I've been getting a lot of questions about the Bop-It controlling the flame effects that we built for an event this summer. I thought I would give everyone a quick tour of how it was made. I'm really bad at documenting the process of making things. I just hate doing it. So, though we worked on this for many months, I came away with just a handful of pictures. And when all was said and done, I have about a 5-second video of it working here. So, here you go. Loop it one more time here. Hit the bop. The poofers go. Now, the way this works, the spin, pull, twist, and flick each control one of the four propane poofers, and when you pop it, all five fire. So there are two components in this system. There's the radio clients, that's the Bop-It, and another device I'll show you in a minute. And then there's the radio receivers, which are what have the relays that open the solenoids that let the propane out of the pipes that lead to the boosh, right? And so I'm going to start by talking about those receiving elements. Let's open KiCad first. So I'll show you the circuit board that's inside of these, and I really love making motherboards, and I use that term loosely to mean a PCB to glue together a bunch of daughter boards, so to speak, right? Saves me a ton of time and lets me lean on the engineering prowess of the people that made those daughter boards, right? I don't want to have to program chips on wafers if I don't have to. So what we have here is essentially a bunch of glue for a Teensy, which is an Arduino-ish thing. It's absolutely overkill in terms of horsepower for this project, but we're running these in adverse conditions, and Teensies I've found to be super reliable when we drag things out into the middle of the woods. The other component is a radio daughter board. That's the NRF24L01 here. And all the rest of this is just I/O and power conversion. So I'll show you the little rendering here. This is what the board ends up looking like in CAD. You can see it's really just a few connections between the Teensy, I/O, power conversion, and on the back you see the Teensy going to the radio. Super simple. Now this is kind of a funky shape because it had really tight space requirements, and admittedly this outline is a little funkier than it needed to be, but I don't always know what constraints I'm going to hit in advance, so I cut away absolutely everywhere that I could cut away, figuring there's some chance that every little nook and cranny here is going to help me fit some wire or something like that, right? So let's close this down and picture time. So I have a couple of pictures here from the build process. Here's one of the brand new boards back from Park, which is who makes this really nice luminous purple solder mask on here. As we start populating it, you see with the headers, some resistors for these lamps that just indicate to you when the two different relays are being engaged. This area here is the daughter board for the radio, the NRF24L01, and you can see I did something silly and undermounted it. And that was a space-saving decision also. The way this circuit board is going to get mounted into its enclosure, I need to have little standoffs back on the underside of it where the screws go through it. And so given that I had to have a little bit of space there anyway, I figured I could put this circuit board on the underside, let the two rows of pin headers stick through the front, and save a couple millimeters, because the daughter board that goes on here is actually pretty tall. and I didn't want to do anything fussy like unsolder these pin headers and all that. I've done that before. It's a lot of work. It's definitely to be avoided. These two chunky guys here are buck converters, so I feed this with 12 volts, step it down to 5, two isolated ones here, one for the microcontroller and the lamps, one for the radio daughter board. Here it is with those daughters populated onto it, the teensy on the left, the NRF24L01 on the right. And that's what it looks like all together with the blank one next to it for reference. So before I jump into the enclosure build out, I'll show you this CAD mock-up of the whole thing. This is actually in Tinkercad, believe it or not, which is really a super beginner-friendly web app for doing CAD stuff, and as long as your shapes aren't super complicated, it works really great. I absolutely hate 3D CAD software most of the time. I hate it because I'm bad at it, and Tinkercad is something that it's really easy to be really good at. So this is the manufacturer's 3D object of the enclosure, and you can see the circuit board we just looked at in green there, and all the other components, which we're going to talk about in a minute. I seem to have actually deleted this CAD file or something. I'd love to give you the 3D pan around of it, but honestly, I don't know what I did with it. So, jumping back into the build out here, I have these lovely Hammond plastic enclosures. This is extremely perma-proto style, so I did, use CAD to make sure everything would fit in the configuration I thought it would fit in, but then everything from there on out is hand cut, hand drilled, and hand measured, right? These Inkbirds solid-state relays are what are actually going to pass the mains voltage to open the solenoids. I'll talk some more about solid-state relays in a minute here. Here's the lamps going through the front to indicate mains voltage coming in, and when each of the two relays fires. There's the PCB, snug against the side there. Oh, some more pictures. I put these gnarly lighting truss clamps on it, and I had to put this massive back plate. You can see this piece of metal here now is the back plate for that truss clamp, and it's sloppily cut, but it does the job. It's really hard to be confident in hanging the weight of this thing off of a lighting truss, given that it's a relatively flimsy ABS enclosure, right? I don't want this thing to rip a crack in the side of it if it gets bonked or just rough handled or anything like that. So these are the outlets, typical NEMA, two regular outlets like you'd plug anything in your house into, and one of the opposite gender of that outlet for you to plug the butt end of an extension cord into and get power into the device. These dorky looking things hanging off each of these are snubbers, which are, in this design, probably actually unnecessary, but before I started using the solid-state relays, I was using typical reed relays, and I learned that the huge solenoids that we were using, when these things are held open by a charge, they create this massive inductive load within them, and when you close them again, turn the fire off, that inductive load is released down the wire, and a typical reed relay has a little bit of bounce when it goes back and forth, right, when it opens and when it closes again, and that bounce tends to create a spark. And with that massive inductive load on the line, it's actually a pretty big spark, and not only does that wear out the relay quickly, but it was EMPing my microcontroller, believe it or not. So I would only get one or two open-close cycles before the circuitry would stop responding until it was rebooted. So the snubbers were an early attempt to fix that. That may no longer be necessary in this design, but aren't hurting anything. I had them already, so I dropped them in here. Here's the whole thing more or less assembled. You can see it's an absolute rat's nest. This is the complete antithesis of design for assembly, right? But like everything else I build, hey, it's permaproto. I only needed to make 2 of these, so this worked out just fine. There's actually reasonable separation of the mains voltage and the control voltages in here. It's not quite as bad as it looks. Lots of room for improvement there, but, it works. So I said I only had to build 2 of these, and I ended up with 2, but I actually had to build one of them twice. If you look at this picture here, something really, really crazy has happened to the plastic. Particularly, you can see it around this nut and bolt on this plug in the corner. You can also see the edges of this sort of shard that has the lamp in it there, and the edge coming up the side of the enclosure here. This was the day that I learned that blue thread lock melts certain types of plastic, so it actually sort of absorbs into it, and all these tiny invisible stress lines that are created during the cooling process of manufacturing the enclosure open up, and the plastic literally crumbles in your hands. This was so crazy. I'd never seen anything like it. Of course, so you go research it on the internet, and sure enough, threadlock and ABS don't get along. So lesson learned. I went and luckily Hammond made this exact same size of enclosure out of different materials, so I went and got a different plastic. And I also just stopped using threadlock in favor of all nylon washers. Here's also showing the lid. This guy in the lid here is a really, really sweet Meanwell power supply. Super high quality stuff. The circuit board in there is potted for vibration and moisture resistance. What I'm actually doing here is converting for the control circuitry, converting the mains voltage down to 12 volts, and then 12 volts with those 2 little black boxy guys on the circuit board I showed earlier, down to 5 volts. And the reason for that is I found that the most straightforward way to all but guarantee really clean power in adverse power conditions, right? So we're running these things in the middle of the woods on God knows what generator, not necessarily a beautiful, clean sine wave coming out of that generator, right? But I really do need a beautiful, clean DC bus in order to run a microcontroller and a radio. So a high quality power supply, mains down to 5, and high quality buck converter, mains down to 12, and high quality buck converters 12 down to 5. Was the most straightforward way I could figure out to do that. I'm not an electrical engineer. I really didn't want to rabbit hole down building high quality power supplies myself, so this just made sense. Here it is, all closed up with the outlets installed. You see the power inlet there on the left and the unoccupied power outlets there. And here's the 2 of them completed. So those 4 outlets on top with nothing in them right now are the 4 solenoids for the 4 poofers that you see in the cool Bop-It video. These guys on top here, those 2 gold bars, are high current, high temperature resistors. They're massive resistors. Something I learned about solid state relays while doing this project is that you need a load on them all the time for them to work. So if, for example, you have nothing plugged into these outlets, or something that consumes no power in its resting state plugged into these outlets, that solid state relay just doesn't open when you apply voltage to the DC trigger terminals. The fix for that was to pull a little bit of current through it at all times. And then the way that gets wired means that when the solenoid is triggered and passes current to the outlet, you're essentially shorting these resistors across the mains, right? So I needed them to, one, be able to tolerate being shorted across the mains, and bleed their heat into the environment, not heat up the inside of my box, not melt themselves after a couple of days of being used, maybe being used in direct sunlight even. So they're big heat-sinked epoxy-filled resistors there, and those red bits on the end are just 3D printed caps to protect the connections where they come out of that gnarly chassis and go into the box there. All right, so that's pretty much everything I have to say about the receiving end. I got to this point in the project, and it was time to think about what the user interface was going to look like, right? And a lot of people, a lot of other folks that do fire art, particularly poofers in similar events to us, I've seen these oversized arcade buttons. These are like 2-inch sort of arcade machine style buttons. They put as many as they need in a box, and they throw it up on the DJ booth or the stage. And I've stood around and watched people have a grand old time slapping these buttons. I think they seem to work really well. And I have a novelty problem. I did not want to make a button matrix because everyone else has got a button matrix, and that's just not a lot of fun for me. So we were sitting around a table in our house, and it was actually one of our housemates that had the idea to make it a Bop-It. And I thought that was about the funniest thing I had ever heard, and pretty accomplishable sounding. So probably later that same night, I went on eBay, I got myself this Bop-It Extreme, and went to town on it with no idea how complicated this would really be, but just sort of a hunch that we could get it to work. I documented this really poorly, but here it is essentially done, right? Here it is opened up with my rat's nest of purple and gray wires there. Put a battery charging circuit where the batteries go, and a giant oversized LiPo rechargeable battery on the other side, so you didn't need to keep flipping double A's in and out of this thing. There's another teensy over here by the pull-it mechanism. That's our microcontroller. There's a radio board buried somewhere in there, and a little antenna cable going up. And this funny looking metal thing here is actually the transmitting antenna just outside of the sort of black plastic sheath you're used to seeing it in. It's a 2.5 gig, so not unlike the old cordless phones you used to have in your house. Same sort of frequency range as consumer Wi-Fi, but a completely home-rolled protocol, right? So I essentially just spam my control bits over the wire, right? I've got this byte of information with some parity bits at the front, and essentially one bit representing each receiving relay. And whenever a control is triggered by the user, that byte gets spammed out over the wire. No transmission control, no retries, nothing like that. Just spam it out there as fast as possible, UDP style, right? No fancy radio library or nothing like that. Here's a close-up. So, of the 5 mechanisms on a Bop-It Extreme here, 4 of them were super easy. They actually, all 5 use these really simple little clicky tactile switches here, right? So you can see This sort of towards the top right, this strap is actually going down towards the pull it mechanism. So when you pull it, you're pulling on that strap, and this little lever here comes and depresses this little button. All the others work very similarly with some kind of, to me, fairly ingenious mechanical coupling between the thing, twist it, flick it, whatever, and the button. And the one that impressed me the most was Spin It. Now, the way Spin It works threw me for a loop, right? So, Spin It is this round knob here, and in that round knob, there's an oval track. In that oval track, there's a sort of a stylus-looking needle here that rests in it. There's a fulcrum here. This little round guy there is sort of coming vertically at you. It's mounted in a little this plastic socket there, and it pivots around that fulcrum, sort of clockwise, anti-clockwise, the way you're looking at it here. And as it pivots around by being turned through that oval track on the round Spin It dial, it depresses a similar little tactile switch. Now, the problem was that when you spin it, you're actually hammering that switch multiple times, right? Each spin goes click-a, 3-5 times. And so rather than simply listening for a rising edge or a falling edge to figure out when my switch is depressed, I had to sort of override that behavior and redefine what, a combination of button presses within a specific duration of time, a combination of rising and falling edges, as a single interaction with the device, right? Obviously, you don't want someone to spin it and the poofer to go clack, 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 right? You want someone to spin it, and just as if they had twisted it, you get one glorious fireball for a moment there, right? So that took a little bit of code shenanigans, nothing too outside of the norm for people that actually deal with hardware and debouncing things and all that. But again, I'm a bedroom everything, so everything here is a little bit novel to me. Here it is, almost all the way back together, utter rat's nest. I think if I had to do this again, I'm absolutely never going to do this again, but if I had to do it again, I would probably print myself some flexi circuit boards to make all these runs, because getting this thing back together with this rat's nest was exciting, we'll say. Again, here it is before I put those Bop-It buttons back on the front and back of it. You can see it's an absolute mess with the battery and the recharge circuitry down there, and you can see the purple wires through the translucent enclosure, and that's no big deal. It almost adds to the fun here. Now, when I put this thing back together, it worked exactly as designed, and that's super, right? But it was lacking a crucial element. I had gutted all of the circuitry in this Bop-It in order to make room for the stuff I needed to be in there. And so when you interacted with it, it didn't make any noise. And not having a Bop-It go and boing and all the other funny sounds it makes was kind of a huge bummer, to be honest. So we went back and decided it's got to make the noises. It's just no fun if it doesn't make the freaking noises. So that's not necessarily a big deal, right? I've already got a microcontroller in there. There's 1,000 MP3 decoder modules to interface with your microcontroller. Many of them are nice and small and could even fit in there despite all the other crap I had squished in there, and that's exactly what I ended up using. And I got really, really lucky. Some wonderful person on YouTube, if you just search for Bop-It Extreme Sounds, has actually ripped all of the audio off of a Bop-It through the headphone jack. These things have headphone jacks on them, remember? So it's super clean. It's as high quality as it could possibly be. And they put it on YouTube, and there's 2 minutes and 51 seconds of it, believe it or not, because of all the things it has to say when you're playing the game and when you switch modes and when you win, and it gets sassy with you when you mess up or lose. So that ends up being almost 3 minutes of audio, which I thought was funny. But this enabled me to get those classic noises and re-implement Bop-It essentially in the hardware that I had built there. So I'm super grateful to the Gaming Siren, who I've never talked to, has no idea I'm doing this, but I am really, really clutch that they had that up on YouTube. So I had this Bop-It that was basically ready to control flame effects. And I hadn't really told the people that I was building the flame effect kit for about this yet. I had half a mind to show up in the field with it and say, here you go, here's your controller, and there is no other one. What are you talking about? But man, it was just too funny to me. I couldn't keep a secret at all, so I spilled the beans months in advance of the first time we were actually going to field this stuff. And the reaction I got was something like, haha, that's hilarious. Where's the real controller? Um, so, okay, maybe that's a little disheartening, but also I get it. So we spent some time talking about what another control surface that's just a little bit more, I don't know, I'm going to use the word a little bit more serious, but still fun might look like. And, we went back and forth for a while, and eventually we decided that some giant mad scientist style levers, like something you'd see in um, Jimmy Neutron's lab or a Frankenstein lab or something like that, like a big suicide switch, knife switch type of thing, right? So I said, okay, that sounds fun. I think we can make that happen. So here's my early CAD mock-up of this. Tinkercad again, great. The white and gray bars here represent the depressed and the released position of these levers. Here's some of the basic components. Now, what really excited me about this is the enclosure. So I could have put this stuff in any kind of box, but I spend a lot of time looking at enclosure manufacturers' catalogs to try and find exactly the right thing. And I've wanted to buy one of these sloped desktop console enclosures for years. I always look at them and think, God, those are so freaking cool. Someday I'm going to have an excuse to buy one of those things. This was that day, which made me very happy. Now, to make the actual levers themselves took a little bit of experimenting. They need to be pretty easy to pull, and they need to return to their resting position automatically when you let go of them, right? You don't want it to be like a boat throttle or machinery throttle where you can depress it and leave it there. You need it to bounce back as soon as people let go of it, because that's what turns the bloody propane cannon back off, right? So I had some wild hairs going with springs and steel cable, and was really coming really close to rolling my own ridiculous solution here. Eventually, I found what you see on your screen here, which are bedroom door closers. I've got this torsion spring in the big white pill side of the guy there, and you mount this on the trim of your wall, and that little bar rests with no tension right against the door. And when you open the door, it winds that torsion spring up, and then when you let go of the door, that spring's got just enough pressure in it to return the door to the closed position. You can find these really easily. They came from freaking Amazon or something. Many of them are substantially larger than this. It took just a little bit of digging to find some that were small. A lot of them have 2 torsion springs, and so they're sort of double as long in the pill shape as this. But these with only 1 spring were just bloody perfect. So here they are, starting to be mounted in the enclosure there. In that first picture, you notice I had little contact switches. I actually didn't end up using those. They sucked. I needed a switch that was as close to indestructible as possible. And I thought back to my music days, and I thought, I've used plenty of nigh-on indestructible momentary switches in guitar stop boxes, or guitar effects pedals. I even had some already, so I broke out my big bag of momentary stomp switches that I thought I would never use for anything after I stopped building guitar pedals, 15 years ago or something. And mounted them in here, and you can see these door closers have multiple holes, so depending on where you've mounted this on your trim, you just screw the little closey arm into whichever of the holes makes the most sense for where your door is. And so and the other thing, they come with these little, they call them like the tensioning bars or something, which doesn't quite make sense. It's a little just stubby bar that you screw in to pull it back after you've installed it to make it easier to screw in the long white arm where you need it, because otherwise you'd be trying to screw this thing in while it's like pressed right up against the wall, and that would be difficult, I guess. So they give you these other little bars. I ended up using them in the hole directly across the diameter of the turning radius from the actual arm that serves as the lever. I took my angle grinder to them and flattened the back side of them that you can't see here, and that way when you pull that lever forward, the small bar depresses the stomp switch. Feels solid, will probably outlive me. I was really happy with this solution. Here it is starting to get wired together on the switch side. Here's another one of these Meanwell power supplies here, and I'm actually using the same power supply strategy where I take my mains voltage, go to 12, and 12 with these no-name buck converters down to the 5 that the microcontroller and the radio are going to need in here. On the circuitry side of this one, I got lazy, or should I say I did a good enough job. So I didn't really want to make another circuit board for this. I love making circuit boards, but it wasn't in the cards. I figured I could do everything I needed to do with one of these perma-proto boards. And it worked out just fine, right? So between these 2 sets of pin headers here is where the microcontroller goes. It's a Node MCU, ESP, whatever type of thing. Here's the radio daughter board that this time I have soldered the pin headers off of and moved them over here to save space, which is obnoxious, but it was fine. And then this dip package sort of under the wires there is an input multiplexer. Since the microcontroller that I was using doesn't actually have enough inputs for me to have the 4 levers and talk to the radio and whatever, right? So this is a super straightforward little input multiplexer there that the switch signals from the levers actually go through. Here it is coming together again. There's my mains input. This is looking just about done here. You can see the radio NRF 24L01 daughter on there with the antenna cable going out the back of the chassis. Here is the back of that chassis. There's the antenna you were looking at in the other one, the IEC input. A lesson about buying cheap crap on the internet. I was really proud of how this looked, and then I powered it on, and this green illuminated rocker switch here. You probably think you know in your mind what that looks like when it lights up, and you'd be dead ass wrong because these cheap suckers have a little incandescent bulb in them that glows a crappy sodium yellow. So rather than being a nice green illuminated rocker like it was in my mind and like it was on a product page, it's a weird yellow green, icky looking thing. But that's okay. All things considered, that's pretty minor. And here it is all together. You'll notice the top of this sloped console enclosure here is routed out really nicely for these four levers. My dad has a beautiful machine shop. I was ready to do this with a drill and a freaking saw. And he said, no, no, come over. We'll use the milling machine. We'll do it right. And it turned out absolutely beautiful. So I'm really grateful to him for that help because I would have never made those cuts that cleanly without the right kit, right? And then those spheres on top are wooden spheres just from the craft store, right? It's like an inch and a quarter wooden spheres painted in UV reactive green paint and then a clear coat. That little LED you see there that's green in this picture, that's actually an addressable pixel in a standard 5mm pitch LED package. And that lets me get just a little bit of information out of the microcontroller to the user, right? A little bit more useful information than just it's on. Since we're actually doing quite a few things here, right? There's this radio client controlling the fire. There's also the Bop-It controlling the fire. These two things can sometimes conflict with each other, right? If person A says fire on the Bop-It and person B says stop firing on here. So it's useful to know when someone might be using the Bop-It. Also, the Node MCU, I built a shoddy but perfectly functional web app over the on top of the Wi-Fi server, HTTP server libraries on that, so you can actually hop on the little isolated access point from the Node MCU, hit the big fire buttons in the browser on your phone and trigger the fire. That's mostly for testing purposes now before there's any propane running through them, just to be up on the ladder and go, tap, tap, tap. Does the solenoid click? Yes, groovy, we're in business. And you can also, in the web app, change the mapping of levers to solenoids or to relays, right? So pretend you set this thing up and you like clamped your relay boxes up on the truss and plugged everything in, and you realize, oh crap, I put B where A is supposed to go and A where B is supposed to go. So now my lever to poofer mapping, rather than going 1 1 2 2 3 3 4 4, is something else, right? It's 1 1 2 is over here, 3 is back over here. You could remap that in software. You can also make arbitrary mappings. So let's say you've only set up 2 poofers, but you want all 4 levers to work. You could make the right 2 both do poofer A and the left 2 both do poofer B, or whatever you want, right? So good time. Works really great. Totally happy with it. And speaking of things I've always wanted to buy, I am a sucker for a good Pelican case. So I really wanted everything to be easily transportable. I wanted to not feel weird about leaving this kit with other people, knowing it's going to be thrown on a box truck and carted out into the middle of nowhere. So I got one of these non-Pelican branded Pelican cases. This is actually a rifle and or keyboard case with the pick and pluck foam. And so that just made the most sense for the shapes of the things that I had there. Turned out pretty cute, I gotta say. All right, pause. All right. Uh, so I no, let's just go through. Unpause. Okay. So at this point, that's all there is to know about the control infrastructure. I unexpectedly had a hand in the hardware mechanical side of the Flame Effects building too, so I'll talk about that just briefly. And this is, boy, this is not my area of expertise, right? So I had professional help, as it were, here. One thing I found really useful when trying to figure out how to build poofers, make fire book. Here it is on Amazon. This guy Tim Deegan, long time Flame Effects old head, has this really excellent book about making flame effects and the art and science of working with propane, as it says there. Super educational. It goes through quite a number of different projects, one of which is Poofer, very much like what we built here. So that was really helpful. Also, uh, Poofer Supply, these people have absolutely no idea that I'm giving them a shout out here. But early on in my realizing that I needed to have a hand in the building of this, despite having absolutely no idea what I'm doing, I found these folks' website and I was trying to put together a shopping cart of the things I thought I needed. This website already made it way easier, right? If you go on a garden variety hardware store or a plumbing supply store, there's every kind of fitting and connector and adapter under the sun. And it's really hard if you don't yet know what the heck you're doing to feel like this stuff that you're just looking at pictures of is actually all going to fit together and be the right stuff. So what's cool about Poofer Supply is it's the stuff you need to make poofers, right? You still got to know in general what you're doing, but it doesn't have all of the nonsense that like an LPG supply store, a plumbing supply store, or something like that is going to have. Also, these people are total sweethearts. I asked for help putting together my cart, and I got an email back right away that said, "Hey, call me." And this lady was like walking her dog around the neighborhood on a 45-minute phone call with me, just educating me about all kinds of things here. Super nice. I cannot recommend this enough. And honestly, uh, I would pay a premium for the stuff on this page because they've done the work of finding it and presenting it to me in a non-convoluted way here. I actually found their prices to be better than many other places, if not all other places in some cases that I looked. So I'm not sure how they're swinging that. But for what it's worth, it wasn't even a premium price tag for this premium service here. So we did eventually get sort of a plan together. I probably, let's come back to that in a minute. I should have pictures of, here we go, the build. Um, Here's a sort of rough sketch of what we ended up making. Yes, this is a Google drawing because I hate myself, and I guess I just really don't want to buy like a Vizio license or something normal to do this on the personal side. So it works. This ended up being really essential for putting together a bill of materials and just communicating across distances, how this thing is going to be put together, making a spreadsheet of where all the parts are going to come from, what the costs are going to be, yada yada. So if you're a flame effect person, feel free to pick this apart. But there you go. So there's just a few pictures here that my buddy sent me while he was assembling them. I did absolutely none of the assembly, but here they are coming together. You'll notice these are 1-inch vent pipes there coming out of these 1-inch solenoids. Absolutely freaking massive solenoids these are here. 110 volt, 1-inch, yada yada. And And there you have it. If you stuck around this long, I hope it's because you were having fun listening to me ramble about my projects here. If you're looking at this on YouTube and you don't know me, well, I'm honored. If you need to reach me, a YouTube comment is about as good a way as any to start the conversation here. So thanks for hanging out.